Okay, so let's move on to question number 2 now. In this question, we are given the mean annual yield of the crop is 8.2 and the standard deviation is 1.2. And we are also given a sample year, right? So we're given 16 years. And what we can see here is that we basically have to test a hypothesis within a 5% significance level if the mean yield has increased. Okay, so what we can see is X here represents the annual crop yield in tons. Then, given X has a normal distribution with mean 8.2 and a variance of 1.2 square. Now for a sample of 16 years, we have our mean sample to be 8.2, 1.2 square over 16, right? So, testing for a 5% significance level, whether the mean yield has increased. If we assume that the mean has a normal distribution of this parameter, then we are saying that the null hypothesis is 8.2. That means the mean has not changed, it's just 8.2. And the alternative hypothesis is to check if the mean has changed, right? So our distribution was this. We have to test our hypothesis in a way to check whether this distribution would still be valid up to 5%. Now, our alternative hypothesis is mu greater than 8.2. If you want to test a 5% significance level hypothesis within a 5% significance level, then we are basically saying that probability of mean is less than C, where C is the limit up to which the hypothesis is valid. Okay, so what that basically means is we have a normal distribution curve like this, and this is the mean, and what we're saying is this C here, okay, if our mean is such that it falls below C, we are saying that our null hypothesis is true. Okay, so this is the acceptance region and this is the rejection region here. So the acceptance region has to be 95%, right? And this is the 5% significance level test that we're doing here. Okay, and we have to check whether the mean has changed or not. I mean, if the mean has, if there's sufficient evidence that the mean has changed or not by a hypothesis test. Okay, then if it's a 5% significance level, it's 0.95, right? So again, if we standardize it, if we standardize this one here, it's basically converting into Z variable, and it's C minus mean by standard deviation equals to this. Again, same as the previous question, right? This is just the inverse of this. Okay, so again, you compare both sides here, and you find out that the value of C is 8.69 up to 3 significant figure. Now we are given in a question that in this 16 years he measured the mean yield output to be around 8.7 tons, right? But our C here is shown to be 8.6. If the measured mean in that 16 years would have been less than this, we would say that there is no sufficient evidence that the mean has changed, right? Now what we are saying is basically that because 8.7 ton lies in the rejection region, there is evidence at 5% significance level that the mean yield has increased. So what we're basically saying is the mean yield of the crop has increased if we look at 5% significance level test. Okay, because this lies in the rejection region, so we have to reject a null hypothesis, which if we reject a null hypothesis means, of course, the mean has increased. We have to write it in a wording like this when we're like looking at the hypothesis test. Okay, so that's it for today. I'll see you in the next question.